At its core, the Spring Security Framework is just a bunch of servlet filters. Servlet filters have been around for about 20 years. They were first introduced in Java Servlet Specification version 2.3 in September 2001 and proved extremely useful. In a nutshell, a servlet filter intercepts a client request and can do some pre-processing. Equally, a filter can take the service response and do some post-processing before the response is returned to the client. So what does it mean in practice? Well, by filtering, we typically mean processing that is common to all client requests and server responses. For example, you might want to log each client request, validate the user input, convert plain text data into a custom data type, or decrypt some kind of a token that's part of the payload. At the same time, you might want to compress a file before returning it to the client, etc. The uses are many. What matters is that the filters are pluggable. The servlet specification defines how you can map filters to front certain servlets in your web application. And one of the areas that lends itself very well to the concept of filtering is security. Certain resources in your web application should only be accessible when the user session is valid. Of course, you can do the validation in each and every servlet or JSP page by looking at the session attributes, but this would soon become tedious and error-prone. What you can do instead is you write a filter that does the session validation for you and plug it into the request processing pipeline. And that's exactly what Spring Security Framework is based on. It ships with a bunch of predefined filters focused on the common security and privacy concerns. You as a developer are only required to deal with a minimal amount of configuration that's flexible and versatile enough to support a range of use cases. It takes you anywhere from a basic or form-based authentication to complex single sign-on authentication flows using industry standard protocols such as OAuth 2, OIDC, or SAML. Another benefit of using filters as the cornerstone of the security framework is compliance with the servlet specification. That makes it easy to plug it into a web framework such as Spring MVC or WebFlux or any other future solution. So long it stays compatible with the specification, it will be easy to plug in and use. Apart from authentication and authorization, the security framework also shields us from common security threats. Why would you write your own filter that prevents cross-site request forgery, for example? The verification steps you would have to implement are unlikely to be unique to your application. Attacks like CSRF have some common characteristics. The framework provides prospective filters for this and other similar fraudulent actions and plugs them into the right place in the processing pipeline. Long story short, Spring Security Framework makes it easy for you to protect resources in your application. It shields you from common threats and ships with sensible defaults. That includes visual components such as a login page. Obviously, more often than not, you will and should override these default settings, but they're there to get you started as quickly and smoothly as possible. Again, Spring Security is based on servlet filters. Any request that is trying to reach a resource such as a servlet, a JSP page, or a static HTML page is processed by a chain of filters. And if the request fails security verification or if the user is not authorized to access the resource, then instead of returning the requested response, the framework rejects the request with some sort of an error code. Here's how the request filtering graphically looks like. The filters always execute in the same order, and if the request passes validation in one filter, it falls through to the next one, gets validated, and if the validation succeeds, the request is passed on to the next filter, and so on, until the whole filter chain is executed. And the processing itself is achieved by calling the doFilter method on the chain object. In this first scenario, the user is trying to access a resource that's only accessible to an application admin. And as you can see, the user is logged in, and the login is valid, but his user role does not grant him admin privileges. As a result, the request is rejected with HTTP 403 forbidden. In the second case, the same user is trying to access his profile page, but since he is not logged in this particular case, the request is rejected immediately with the HTTP status of 401 unauthorized. Which brings me to the next topic, the distinction between authentication and authorization. To make it more specific, I've pasted a snippet from my IDE where I was debugging the authentication step. As you can see, the user has logged in with his username and password. Authentication then answers the question, who are you? In this case, I know that the username is Bob and that the real name is Bob Doe, and the user is also identified by his email address. Authorization, on the other hand, answers the question, what are you allowed to do? In my case, the user seems to have just simple user role, meaning that he will probably be able to view and edit his own profile page, but he most likely won't be able to view and edit information about any other users in the system. Here's the filter chain in detail. Some of the filters shown here have been adjusted for reactive web, but the chain would look pretty much the same for the traditional MVC model. As I said, the order matters. So each request is thus validated by the chain of 12 filters, and only then is the response returned to the client. The validation starts with an entry point. This very first filter establishes what is called a web exchange as a contract for request-response interaction. This enables the entire mechanism for inspecting of the request and modification of the response before it's returned to the client. The next filter writes response headers before the response is committed. Next, CSRF protection is applied, so cross-site request forgery protection filter. The protection is enabled by default and the CSRF token is stored in the web session. More information on how CSRF works is in the description section below the video. The next filter in the chain is, it establishes what we call a security context. Security context simply contains the currently authenticated principals, such as the user password token I showed in the previous slide. Over to authentication handling, displaying of the default login page is form authentication is what you want, and so on and so forth until the authorization check at the end, just before the requested resource is returned in the client response. Here I have highlighted some of the filters that are easier to understand. You can override most of the default behavior by configuration, and in my upcoming course I'll show you exactly what to change and what you can safely leave with defaults. Speaking of the configuration, there is this Fluent API whose sole purpose is to configure the filter chain. For example, if you debug the HTTP object implementation, you will find out that the CSRF protection is indeed enabled by default. Or if you opt in for a form login, then you will come to a place where the default login page is generated for you, and once you submit credentials and the login is successful, the framework will redirect you to the root of your web application. Obviously, you can redefine most of this, but it's good to know what to expect by default. Last but not least, I wanted to briefly mention why I chose WebFlux over Spring MVC. Reason number one is the lack of documentation. Spring Security applied to reactive web is somewhat underdocumented, I felt, and that was indeed the initial trigger that made me start this series. And apart from that, well, I gather we all strive for great scalability and lower cost of running our services either on-prem or in the cloud. So reactive web comes with certain undisputable advantages that will give your application an edge when it comes to scalability. It consumes less resources, fully non-blocking I/O, etc., etc. And I will talk about these and other benefits in detail in the upcoming tutorial. Obviously, reactive web is based on different principles and requires a shift in thinking of how you think about your programming model. But the transition isn't as steep as you might think. There's a great deal of overlap between the traditional MVC model and WebFlux. So it's totally worth it to these days to transition to reactive web, and there's a great level of support in the Spring framework for that. This brings me to the end of what I wanted to talk about today. Thanks for watching thus far. What follows is a hands-on tutorial on Spring Security and how it applies to reactive web. In just a few episodes, we will write a simple reactive web application and cover most of the typical security requirements. First, I'll show you how to successfully plug Spring Security into your project. Next, we cover the absolute basics. We create a bunch of users, store them in a database, and I will show you how to load the user details in a non-blocking manner and use them for authentication purposes. Moving on to cool stuff, such as single sign-on with social networks. It's in fact fairly easy to do and totally worth a try. And then we take it to the next level, and instead of just tweaking what's given, we create our own security filter that deals with passwordless authentication, where you just send a magic link to someone's mailbox and they don't even have to be a registered user. As part of the course, we will learn how to prevent unauthorized access to our application and shield against some of the common attacks. Each episode ships with a complete source code and a bunch of useful links to documentation, articles, videos, etc. So don't forget to subscribe to my channel. Don't miss out on new content. Every week there will be a new episode. I believe that gives you enough time to catch up and experiment on your own. Follow along, have fun, and definitely let me know your thoughts and feedback. I will do my best to reply in a timely manner. Thanks again for watching, and see you around in the first coding session on Sunday next week.